So let us start. The equation 1 defines the modified nonlinear Schrödinger model in which the psi field, complex psi field, depends on x and t. So from this equation and its complex conjugate, one can write this quasi-conservation law such that this beta hat n represents an anomaly. It's written in this form for n equal to 1, 2, 3 and all positive integers. So from this equation one can define a charge, quasi-conserved charge, such that its time derivative is equal to the integral of this anomaly. So the interesting thing is that this anomaly, the space-time integral of this anomaly vanishes provided that this psi field satisfies this symmetry. This is just a special space and time reversion plus complex conjugate operators. So if this property is satisfied, one has that this anomaly, the integral vanishes. So one can define from this relationship the quasi-conserved charge or asymptotically conserved charge such that its value remain the same at far future and the past, the remote past. In the next slide we will present the numerical simulation of this anomaly for two soliton collision. So this plot shows the initial time soliton configuration, the green line. Here is the blue line shows the collision time situation, and this red line represents after the collision of the two solitons. Here in this plot, this is the x-axis. This is the anomaly for initial time, green line. This is for blue line is for collision time, and this red line is for after the collision time. So we integrate this density, integrating x. So one has this plot. This is the t-axis, and this is just integral for x of this anomaly, and one can see that this vanishes within a good approximation. This is around 10 to the minus 12 order of approximation. Here one has the xt integrated anomaly. This is the t-axis. In this case one has that the anomaly vanishes with a very good approximation. It's around 10 to the minus 16 order of approximation. So the next slide presents the linear system formulation of the model. Here ax, at, a tilde x, a tilde t are potentials, some potentials. Q and q bar are the fields of the model. This a0, a1, b0, b1 are auxiliary functions. So one write this linear system of equations in which is phi and phi tilde are it's a vector. This S is a matrix, diagonal matrix, so that one can establish this equation, zero curvature equation. From this equation 7, one can get the modified nonlinear Schrödinger equation presenting the first equation. So for q equal to psi and q bar equal to psi star, one has that this 7, equation 7, reduced to the equation 1 in the first slide. Next, for this field chi defined in this form, in which this a sets are just this potential components, one can write an infinite set of non-local conservation laws in this form for n equal to 1, 2, 3 and all positive integers. Thank you.